Hello everyone and welcome to my third and final video for segments and midpoints. We are going to start on page 43. Example A is an example that goes through some problems. I'm not going to go through this. You're more than welcome to read it on your own and ask me any questions. It is very similar to these problems I'm about to do, so there's no need for me to go over one that's already done for you in the book. So let's go ahead and just start with the try these A. Again, we're on page 43. So let's take a look at A. If y is the midpoint of WZ. Now, I'm not going to do anything else at this point except literally draw this out. So WZ is going to be my line segment. So I'll go ahead and draw some random line segment. And just a heads up, I know I'm always drawing the line segment horizontal, but it could be diagonal, vertical. It could be anywhere, going in any direction. I think it just makes most sense for people when you draw it horizontal. I think it leads for the best way of actually being able to write the workout and stuff. So it's WZ, so it doesn't matter which one's which. I usually go left to right. That's just the way I work. And then Y is the midpoint, so somewhere in the middle I can put Y, and I'm going to put those tick marks to tell me that those two line segments in between Y, WY and YZ, are going to be the same. So they tell me here YZ is X plus 3, so I'm going to label that. They also tell me WZ is 3x plus 4. Now, WZ is the entire line segment. I'm sorry, 3x minus 4. I think I said 3x plus 4. Sorry about that. So now we need to determine the length of WZ. So I think there's really two ways you can handle this. I think the easiest way for people, maybe I'm wrong on this, is to, if I know YZ is X plus 3, then so is WY. And these two segments are the same, so I'll go ahead and just write that into my picture. And then now what I want to do is I want to solve for X. So I have to set up an equation that's going to represent this. And basically the two halves of this line segment will add to be equal to the entire line segment. So the two halves are the same at X plus 3. So I'm going to add those together twice. And that's going to be equal to the entire line segment, which is 3x minus 4. All right, so that tells me that basically WY plus YZ equals WZ. All right, so that's that segment addition thing that you learned yesterday if you're doing the folders in order or in the previous folder, however you want to think about it, is I know that the two pieces are going to add up to the whole. So the YZ, I'm sorry, WY and YZ add to WZ. I then, substituted in those expressions as you can see here. Now it's just a matter of solving for X. I'm going to combine like terms. X plus X is a total of 2X. And 3 plus 3, sorry, that shouldn't go there. This plus is included when I added the x's, and then this plus is with the 3, so plus 3 is a total of plus 6. Right, so I combined those. I had an x plus an x for 2x, a positive 3 plus 3 for 6. The right side hasn't changed yet, so that's still equal to 3x minus 4. I want all the x's on one side, so I'm going to subtract this 2x on both sides. That's going to leave me with 6 equals, sorry, there should be an x here. 6 equals x minus 4. Add the 4 to both sides, and we get x equals 10. Right, so 6 plus 4 is 10. And let's go back. What is the length of WZ? So they don't ask me to find X. They ask me to find the length of WZ. I know the length of WZ is, they told me, was 3x minus 4. Right, you can see that here. right? So 3x minus 4 is WZ. So if I plug my new x into here, so 3 times 10 minus 4, 30 minus 4, 26. That's going to tell me that the length of WZ is 26. Right? And that's going to answer this question. All right, so here's a shot of all that work. You can pause it and write that down if you need to. You can always ask me questions. All right, so I took the 1/2. I made the other half the same value. Both of them are x plus 3. I added those two together and set it equal to the entire length of the line segment, which was 3x minus 4. Solved for x and got 10, plugged x back in to 3x minus 4 to get 26. If you wanted to check it, you could plug the x into here, right? And that would give me 10 plus 3, which is 13, right? That's the same on both sides. Whoa, I don't know what happened there. Right, 10 plus 3, which is 13. 13 plus 13 would give us a total of 26, which it did work out. Right, so checking my x told me that both halves were in fact actual halves of the whole thing being 26, each half being 13. So that's something you can do to check your work. All right, so let's take a look at B. So it's kind of confusing here. A ends right here, and then B starts with this given, so we need that. Given M is the midpoint of RS. Use the information to find the missing value. So again, M is the midpoint of RS. I like to draw the picture. Here I'm going to have some generic line segment where R and S are the endpoints, and then in the middle is M. And again, the tick marks are important just visually to see what's going on. They tell us RM is x plus 3. So RM we'll do is x plus 3. And MS is 2x minus 1. So here they're giving us an expression for both halves. One half is x plus 3. The other half is 2x minus 1. And the only thing we know about these two halves is that they're the same. They're equal. So I'm literally going to take each of these expressions and set them equal to each other. Right? That's the only thing we know at this point, is that these two halves are the same. So if they're the same, I can set their expressions equal to each other, and then I can solve for x. Again, I always like to get all the x's on one side, so I subtract x on both sides. That leaves me with a positive 3 after those turn to 0. 2x minus x is 1x, and then the minus 1 didn't change. And then you can just add the 1 to both sides. And that's going to give us x equals 4, which is not what they're asking. Well, they do. Sorry, they do ask x is 4. But they also ask for Rm. So again, you're going to take Rm, which is x plus 3, and you're going to plug in that x equals 4. So 4 plus 3 is 7. Rm is 7. If you want to check, you could also plug it into the other side. So 2 times 4 minus 1 is 8 minus 1 is 7. Since those are both the same, you most likely did it right. So there you go. We have that for B. Okay, so again, the way we do B is we drew a picture. We realized the two pieces they gave us are halves, so they're equal to each other. We set them equal to each other, solve for x. They wanted Rm, so we found the expression for Rm, plugged in that x, got our answer, and then we plugged it into the other half just to double check that they were both the same, which they were, and we're good to go. So we're going to do the same thing for this next one. I'm going to probably move it a little bit though. So I'm going to just go ahead and draw this picture. I know again that we have some random line segment that is RS with a midpoint M. So that means these halves are the same. RM is x plus 6, so I can go ahead and label that. And RS is 5x plus 3. So you have to be careful, right? RS is the entire segment. So the entire segment is 5x plus 3. So this is different than the last problem we just did. In part B, The two halves were the same. We set them equal to each other to be able to solve. This one is going to be more like part A, where they gave us one half. We made it both halves the same thing, added the halves, set it equal to the whole thing, and solve. So let's go ahead and do that in a much quicker way since we've already done it once. All right, so here we go. The first thing I do is make these two the same since they're equal halves. I'm then going to add those two together and set that equal to the entire length as an expression, which is 5x plus 3. I'm going to combine like terms. X and x is 2x, 6 and 6 is 12. And then I'm going to solve by moving the x's all to one side. So I'll subtract 2x on both sides. That gives me 12 equals 3x plus 3. Subtract 3 on both sides. So that gives me 3x equals 9. Divide both sides by 3, and we get x equals 3. Now let's go back up and see what they actually ask us. They do ask for x, which is 3. And then they want to know SM. So SM we know is the same as RM, which is x plus 6. So I can go ahead and do, x plus 6, but now I'll throw in x is 3. So I'm sorry, that should be 6, not 3. X plus 6, x is 3, so 3 plus 6 is 9. And I can double check. If half is 9, then the whole thing should be 18. So 5 times 3 plus 3 is 15 plus 3 is 18. So it did work out that SM was half of what the whole thing should be. So that was just a little check there. And I know I said that this was the last video, but I'm going to go ahead and end this video here. I think there was a lot going on. And it was kind of long, so I'll do another video with the rest of the problems in this section. Again, if you have any questions, just send me a message.